Hi, this is the Correlation Podcast. Works alongside Handbook 7 and looks at the parametric and non-parametric tests of correlation. So when to use correlation? Well, if you have two continuous variables you want to investigate and quantify the relationship between, you may use correlation. And correlation doesn't assume there's a causal relationship or cause and effect relationship between the two variables you're looking at. The two most commonly used correlation tests that we use are the Pearson's correlation, that's our parametric test, and the Spearman-Rank correlation, which is our non-parametric test. In this podcast and in the handbook, we're going to use the trees.csv dataset. This is available on the Science and the Environment undergraduate program Moodle page, where all of our data is stored, but also you can access it directly from in our Commander. So we'll do that now. Let's import the data. So if we go to Data, Data in Packages, and Read Data from an attached data set. As we did in previous podcast, type trees in there and hit OK. If everything's gone well, it should be blue at the bottom here, which it looks pretty good to me. And then you view your data set just to make sure. It's always worth making sure that your data is imported correctly. So we've got three continuous variables. We've got girth, height, and volume. Okay, so our data is in correctly. So the first thing you might want to do is, if you're looking for a relationship between or correlation between two variables, you may wish to plot the variables. And the easiest way to do that is to use a scatter graph. So if we go to Graph, then down to Scatter Plot, select the variables that we're interested in. So interested in girth and height of the tree. There's a lot of different options that you can select here. Because we're looking at correlation, we don't want any of this extra information, so just untick all the extras here. You can leave the X and Y label to automatically apply, so that'll apply whatever the variable name is, but it may be worth giving the graph a title. So I'm just going to call mine Figure 4 and call it Trees. You'd call whatever graph you were creating, give it a name, give it a title relevant to what you're doing. Then click OK. Okay. So this is our scatter plot that's been produced. As you can see, there does seem to be a bit of a pattern of positive correlation between the variables. So as girth increases, height tends to increase. There are some outliers, but the general pattern does look like there is a correlation. So we may want to quantify this and to actually determine whether this correlation is significant or not. So the first thing we need to do, as we have with many of the other tests we've done, is test for normality, because that's one of the assumptions. We need to know whether our data is normally distributed to determine whether we're going to use parametric or non-parametric tests. So let's go back to our data set, go back to our Commander. If we go to Statistics, Summaries, Shapiro-Wilks test, we have to do each variable one at a time. So we'll do girth first. And in this case, we're looking at our p-value again. We're looking to see if it's above or below 0.05. In this case, it's above 0.05, so we know it's normally distributed or not significantly different from normal. Now we need to test the other variable. So we'll get to Statistics again, Summaries, Shapiro-Wilks test and normality, and let's do height. And again, both values are important, but the p-value tells us whether it's significantly different from normal or not. In this case, it's above 0.05, so our data is normally distributed. There's no significant difference. So with both of our variables being normally distributed, we can use our parametric test of correlation. And this is our Pearson's correlation. So in order to do that, if we go to Statistics, click on Summaries, and click on Correlation Test at the bottom here. It's in this box here, it's asking you to pick two variables. So if you select girth and then hold down Control and then select height as well, ask you which test you want to do. In this case we want Pearson's, and then you can click OK. So these are our results here. This is our Pearson's correlation results in the output here. So there's a few different values that are important here. first of all is the correlation coefficient down here. This ranges from 1 to -1, with 1 being a positive correlation, -1 being a negative correlation, and 0 being no correlation. So in here we've got about 0.519 or 0.52. Then we also have our p-value, which tells us whether that correlation is significant or not, and in this case it is significant. It's below 0.05. So if we were going to write this up in a report, or you were going to put it in one of your papers, you may write something like this. I'm going to write it in, type it into the script screen there. So you may say a significant positive correlation was found between tree girth and tree height. Then in brackets you'd put the correlation coefficient or the core value. You put the degrees of freedom, which is 29. That's down here. And you'd also report your p-value, which in this case is less than 0.01. You could report it just as 0.002 or rounded up to 0.003. But either way is acceptable. Okay, so based on those results, if you're putting these in a report, you may write something similar to this, and you may put the scatter plot in we did previously. If we did this example and we found our data wasn't normally distributed, and our data showed a significant difference from normality, doing a non-parametric test is very similar. So we go to statistics, go to summaries, go down to correlation test again, and the only difference between the two tests is selecting that there. That's our non-parametric test, Spearman rank order. Again, once you've done that, our variables are both highlighted. Just click OK, and our results come up here. So again, we're looking to see whether it's positive or negative correlation. In here, it's above, it's 0.44, so it's positive. So there's a positive correlation occurring, and we're also interested in the p-value, which again tells us there's a significant correlation between tree girth and tree height. If we're writing this up for a report, again, you may put the scatter plot in with your in your analysis, but you may also write something similar to this. You may say a significant positive correlation was found between tree girth and tree height. You'd report the RHO value. You'd report the N, because notice there's no degrees of freedom given, so you just put the sample size, and then you report the p-value. In this case, it's about 0.01. So that's very quickly how to perform correlation tests, both parametric and non-parametric.